Hey kids, this is section 9.4, solving quadratic equations by graphing, coming at you. This should be a good lesson. I'm excited to go through it with you. This is not, though, the best lesson in the world on solving quadratics by graphing. These are just the high points from the lesson. This is not a complete lesson, just the high points for kids who need a refresher, just an extra view of the high points. So that said, please don't assume that this is a perfect replacement for attendance or attentiveness to class. This is just to help kids from home. So let's get started. Our objective is to solve quadratics graphically. Now previously we have solved linear equations graphically, and I want to start this lesson with a contrast between the difference between graphing linear equations and graphing quadratic equations. So like linear equations, we can find x, the x-intercepts, that's the solution of the equation, by subbing in 0 for y. The reason for that is the solution for x is going to be the x-intercept. And no matter where a line crosses the x-intercepts, that coordinate is going to be some number and then 0 for y. And so that's why we can sub in 0 for y to find where the x-intercept will be. So previously we learned for a linear equation then to find a solution by graphing we could do 0 equals 1/2 x minus 2. And then to continue to solve for the variable, solve for x equals 1/2 of x, multiply by 2 to isolate the variable, so 4 equals x, or x equals 4. So therefore we could expect the point 4, 0 to be the x-intercept of the line that is represented by this equation. And as we can see, when this is graphed, 4 intersects at the x-axis right on the line. So we can show that all of those things go together to prove that x is the value of 4, or 4 has the value of x, or 1/2 of 4 is 2 minus 2 is 0. Now similarly, we can do the same with quadratics. We're going to find where the graph of this equation crosses the x-axis. So again, I can substitute 0 for y, 1/2 x squared minus 2, solve for x, same as before. Just now, instead of an x, I happen to have an x squared. The reciprocal of 1/2 is 2. 4 equals x squared. And remember, to solve for x, to isolate x, the reverse of squaring a number is finding its square root. And so square root of 4 is 2. And technically, both positive 2 and negative 2 are square roots of 4, because 2 squared is 4, negative 2 squared is 4. So therefore, because both of those are square roots of 4, we could expect the points negative 2 and 0 and 2 and 0 to fulfill this equation. They would be x-intercepts. And with a quadratic, we do not form a line, but we create a parabola. It's a fun word. It is not parabola, but sometimes we joke about that. And so here are your points, negative 2 and positive 2, satisfying the quadratic equation. So it's very similar to what we've already done, just another, layer on what we've already learned. So I think this is really interesting stuff. Okay, so here's the big idea. You can solve a quadratic equation a lot of different ways, actually. This is just one small thing. Equation. By identifying the x-intercepts of a graph. Now this only works if you have a graph. If you don't have a graph, then you get to make your own, which is a different lesson. All right, flip to the back. So this looks complicated, but it's truly not. We are just solving by viewing a graph. So let's try it. This is the quadratic. And you could solve this using the quadratic formula. You can solve this, you could create a graph by finding the vertex, negative b over 2a, then plug that in to find the y, make a table of values, count up, count down, fill in that all those things. We're not going to do any of those things. There's a lot of things that we could do here. We're not going to do those things. We are just saying here, this is the quadratic, this is the graph that goes with it, and we're just assuming that all that is true. So we're only looking at where the parabola intersects the x-axis, and it appears that it intersects at 5 and 2. So therefore, we would expect that the numbers 2 and 5 can be substituted in for x and have that quadratic balance out. Now, rather than have you sit here and watch me show that work, I have that prepared for you ahead of time. Look at there. This time I subbed in 2 for x to show that it balances out to 0. The reason why we say 0 is because where the parabola intersects the x-axis, it would be 2, 0, 5, 0. So we sub in 0 for y. And then here when I sub in 5, we balance out to get 0 again. So this works. All right, let's try another one. So this is the quadratic. This is the graph generated by technology, graphing calculator, computer, whatever. And so it intercepts here and here. Be careful, this is a 10, so that makes me think these are numbered by 2. 2, 4, 6, 8, 10. Yes. So this is 6 and this is -4. We write the solutions in ascending order. And so I can be sure that I am correct if the graph wasn't clear enough by substituting -6 and 4 into the equation. And in fact, that works. If I plug in -4, balances out to 0. If I plug in 6, it balances out to 0. And so it works. Now we kind of have a cliffhanger here. We have an uh-oh. What if my graph looks like this? What if I zoom in and my parabola does not clearly go through an intersection point on the x-axis? This is not a perfect intersection, and this is, sometimes not something we want to estimate. What if we were measuring something really important? So there is a mathematical way that we are going to learn in our next lesson, but for now, we're going to keep it simple. I just want for you to know the concept that you can look at a graph of a parabola and find the value for x. So on your homework, we joke about this is probably like the easiest homework that you will ever get all year long with me. So enjoy it while it lasts. This is simply all you were doing. I can't even show you A because this is so easy. I cannot rob you of any more opportunities. So this is, again, parabolas generated by technology. These are the intersections. So these are also roots. They're called roots. This part of the parabola, these are also called legs. We're getting into some pretty technical vocabulary. So this is positive and -2. You could either write -2 and +2, or you could do positive -2, like so. So this one crosses here and here. Negative and positive. What am I doing? Positive and -3 would be your solution. Here intersects at 2, 3, 4, 5. 2, 5. And that's all we're doing, is identifying where the legs of the parabola intersect on the x-axis, and knowing that that is going to be the solution for that equation. So that's a short lesson, short and sweet. I hope this was a helpful refresher for you. If not, if you have lingering questions, do not hesitate to contact me at d231.rochelle.net. I would be happy to help you. Don't hesitate at all. Thanks a lot. We'll catch you back in class. Bye.